Okay, so this is like a practice problem sort of situation, and what I want you to do is to generate all possible resonance forms for this that are meaningful, and then evaluate them and decide which one is the most stable and why. I'm going to run through this in a second, but it'll benefit you greatly if you can generate this on your own. So take a stab at this problem. Okay, so if I'm going to try to figure out which of these, how to generate additional resonance structures, the best thing to do is to find areas where there's too much electron density and you try to spread those out. Or I can try to find places that will tolerate having more electron density and pull electrons there. I'm looking at the structure that is neutral to begin with, so there is no obvious problem to solve. If there was a charge, I would try to solve the problem first. But this structure has no charge, therefore it has no problem. Do I have places with a little bit of extra electron density? Yes, this nitrogen has it, this oxygen has it. Do I have places that can tolerate having more electron density? Yes, this oxygen can tolerate more, and this nitrogen can as well. So I could start by trying to use those lone pairs, or alternatively, I could start by trying to take, say, this double bond and shifting it to a place that can tolerate having more electron density. Right now, this oxygen is happy, but if I were to take this double bond, which is of course shared between the carbon and the oxygen, and move it so that it becomes a lone pair on the oxygen, so it becomes property solely of the oxygen, then what that will do is create a new resonance form. So let's do that. So the result of pulling this double bond and making it into a lone pair is that now the oxygen has 3 lone pairs and therefore carries a minus charge. I have taken what was 4 bonds to this carbon and turned it into 3 bonds to this carbon. Since there were no hydrogens there, then now this carbon lacks an octet and therefore it has a plus. I did not have a problem in the beginning, but now I've created a problem. On the other hand, I was looking for all meaningful resonance forms, so this is in fact one of them, even though it is substantially worse than the original. Having said that, since the original was neutral, everything else I generate is going to be worse. So I'm okay with it being worse. This one is not out of the question. This one does not bother me. Can I move on? Can I generate another one? Well, now I have an area that lacks electron density and an area of great electron density. So I could obviously go back in the opposite direction and return to where I came. So using this blue arrow, I could make a double bond there. And obviously what that does is take me back to where I started from. So is that moving in a helpful direction? No, it just simply returns to where I came from. On the other hand, that's how you get back. And so this is, in fact, a valid set of resonance structures. Okay, so I lack electron density here, and if I can't use this extra electron density to solve it, where else do I have electron density? Well, the answer is this nitrogen has a bit of electron density to share, so I could take that lone pair and turn it into a double bond, and that would at least solve the problem of my plus. It doesn't do anything for the problem of the minus. On the other hand, the original structure did not have a problem, so I'm accepting some problems just because I'm generating new resonance forms. So this then will lead to a new structure as well. Of course, now that I've generated this form, what I see is that the oxygen remains unchanged. It was minus here, therefore it's minus there. The nitrogen, by forming a double bond, has now taken the plus charge for itself, but at least now we have a full octet on this carbon. If I would like to return from this structure back to this red structure, all I would need to do is to take this double bond and convert it into a lone pair on the nitrogen. That would then return me to here. If instead I wanted to go from the yellow structure all the way to the blue structure, the way I would do it is first take the lone pair from the oxygen and create a double bond with it, and then that will be the thing that causes the double bond between the carbon and the nitrogen to become a nitrogen lone pair. So the pink arrow returns me to this structure. The set of 2 blue arrows would return me to the original structure. So this is how I generate the resonance structures for the molecule, and these are, in fact, the 3 resonance structures that I would want you to draw. The original, of course. Then this would be worse substantially than the original, and I would describe this one as also worse than the original. But now comes the extra question, which is evaluating them. Which one do you like best? So the null answer, of course, is the one with no formal charge is going to be best. Obviously, this is better than these 2. So now the key question is, which of these 2 do you like better? Well, they both have an oxygen with a minus on them, so that's going to be a point of similarity, not of difference. So what we're doing to figure out which one we like better is evaluating whether we prefer to have no octet on the carbon, but it has a plus on the carbon. Here we have full octets on everything, everything, but where's the plus? Plus is on the nitrogen. Okay, so now we have two things that are in some conflict with each other. A plus on a carbon is better than a plus on a nitrogen, in the sense that a carbon is more electropositive than a nitrogen. A nitrogen is somewhat electronegative. Therefore, we'd rather have a plus on the carbon than on the nitrogen. If you have a choice between those two, plus on carbon would be better than plus on nitrogen. However, the reason why there's a plus on the carbon is because that carbon doesn't have an octet. And the reason why there's a plus on nitrogen is because the nitrogen would like to have a lone pair. But everything has full octets. This carbon, this nitrogen, this oxygen, all the R groups, everything has a full octet in the structure. Here, the reason why there's a plus on the carbon is because it lacks an octet. Therefore, which one is more important? Which of those two factors is more important? Well, having full octets on everything is more important. This is the second best structure. The best is neutral. The second best structure is the one where everything has a full octet. That is more important than the electronegativity difference between carbon and nitrogen, where, yeah, in the abstract, you don't like to have a plus on an electronegative atom. On the other hand, the reason why you have a plus on this carbon is because it lacks an octet, and that's bad. So this one would be worse. This is the third best resonance structure of the three. The best is everything neutral. Second best is everything with full octets, even though that's bad from an electronegativity standpoint. Worse is no octet on the carbon, even though that puts the plus where you'd expect it. The octet rule is the rule that matters most. The other ones are secondary to that. Which of these structures most accurately represents the way the molecule looks? Well, the more stable resonance form is going to be the way the structure looks. So the structure is going to be given by the best resonance form. But the way this molecule reacts is going to be given by the minor resonance forms. In other words, when you look at these minor resonance forms, what you should be aware of is this oxygen is more minus than you think. This carbon is more plus than you think. There are reactions that will attack that carbon with minuses because that carbon has more plus than you think. Likewise, this nitrogen is more plus than you think. It isn't acting like a normal nitrogen in some sense. It's acting like a nitrogen that's relatively plus, whereas the oxygen is reacting as though it is relatively minus. The structure, the way the compound looks, is given by its best resonance form, but the way it reacts is going to be given by those minor resonance forms, which is why it's useful to generate them. The oxygen's more minus than you think, the nitrogen's more plus than you think, this carbon's more plus than you think, and that will govern the way amides react.